Hi friends, Namaskaram. This is Nitesh Kumar and welcome to my YouTube channel. So today the topic will be why the current transformer gets blast. What is the reason that a current transformer gets blast, and we will discuss some of the root cause basic reason in this video. So recently I visited one of the site. My friend is deputed there, and on the day when I went there, this incident happened. One CT current transformer blasted that was installed erected in the bay of a transformer bay in a 400 kV substation. So that day we stayed there and we found some of the reason. We were doing some root cause analysis, and we were trying to find that why that current transformer blasted, why it exploded. So we found some of the reason that experience I want to share with you. And really you must know this, because if you are an engineer, if you are depicted on a site where there is a operation and maintenance of a substation, whether it is in a you are in a power plant, or you are in a substation, or you are an engineering student or an electrician technician, so you must understand this basic reason and the root cause, so that you can prevent such an incident against that. So okay, and I'll show you one of short video that incident occurred there. Okay, so let us see. So in this picture you are looking at the people's, the security guard and all the people's, whoever was working there, they all came and they tried to just stop the fire. Okay, but before showing everything, I would suggest you and recommend you to follow the safety rules, like wear helmet, safety jacket and safety helmet, because in this video those peoples are not following the safety rules, and they have not the they don't have the PPs, personal protective equipment, but you please follow that. Okay, so in this picture you are looking that there is some fire on the pole erected of the current transformer. So there, that cable is burning, that cable which is connected to the secondary terminal of the CT, that cable is burning. Okay, so and that tank, CT tank, that tank blasted and they fell down just behind that. Okay, that also you will see in this video. Okay, so these people try to stop the fires using the fire extinguisher also, and they are spreading the sand and soil, whatever they are getting that near to that. Okay, using that fire bucket. Okay, but you must have to use the safety before doing anything. If you are in operation duties and you are in duty, you have to report, and suddenly you have to take the action also, but don't be in hurry worry. Please protect yourself and use the safety PPs, and then you go on site to take the action whatever is recommended there. So here you are looking that, see that tank. Okay, that tank blasted and that fell down. You see, you are looking that winding, and that winding is burning in that video. And this side, that yellow LA is, that is lightning arrestor, is also affected. Okay, once current transformer blasted, that affected that LA also, so that LA also fell down there. Okay, this is the B phase current transformer in transformer bay, and such incident occurred. So whenever you are going on duty, you must have to check all the things, like that the region why it blasted, as a root cause analysis be found, and that region I am going to discuss in this. Okay, so friends, this is another video where the current transformer is just blasted in a 400 kV switchyard. See, this is the live photograph. This is a live video shooted by the CCTV camera you are watching. So the purpose of is to just show you that how the city gets blasted. Okay, this is the live scene you are watching, so that you can have an experience and be aware. Just be aware before going to the switchyard at the time of inspection or anything, and you have to follow the basic rules and things to understand. So if we talk about that what caused current transformer to explode, then the first reason is that secondary circuit must not be kept open. So the arrow indication is showing in the picture is the secondary circuit. So on the top you are looking that PP, that is the primary winding. Okay, and in the blue color, the blue circle is the secondary winding. Okay, so here you are looking that 2S is there. First one is this and another one is this SS. That it seems like it is in an open circuit, okay, but practically it should not be open. Always it should be closed, it should be sorted, okay, through loop. If it is in a normal condition, then it should be looped through a wire, or you have to connect the relay or warden to it. For more picture, just understand practically in the secondary winding on site. If you see, the secondary windings will be indicated like this: 1s1, 1s2, 2s1, 2s2. This yellow color is shown like a wire, okay. This yellow color wire is looking like it is sorted, okay. So 1s1, 1s2 is sorted, 2s1, 2s2 is sorted, okay. So like this, the picture secondary winding, secondary terminal should be sorted, okay. So with this picture, it is very much clear for your understanding. This arrow, red arrow color is shown here, okay. Next, third one is that, second one is that never disconnect secondary circuit from burden. What is meant by burden? In the picture here, you are looking that this one is the primary, okay. This one is the primary winding of the CT. At the bottom, this is secondary winding of the CT, and you are looking that this secondary winding is connected with the ampere, okay. Instead of this ampere, the relay shall also be connected, okay. So you are looking that there is a closed path of the current from the secondary winding to the ammeter, and then it is making closed path like this, okay. So you can say that the secondary circuit of the secondary winding is in a closed path. That means it is in sorted condition. That means you cannot say that it is in open condition, okay. So here in this picture, you can say that this is the burden. How it is burden? Burden means the resistance of the cable from the secondary terminal of the secondary winding to the relay, okay. So that means the resistance of the cable and the resistance of the coil inside the ammeter, or the resistance of the coil inside the relay. This two resistance is called burden for this secondary winding, okay, in this secondary circuit. So you don't have to disconnect this ammeter and relay from the secondary circuit, otherwise it will be in open condition. Next point, next is, and very important, is the oil level must be above marking level in CT winding tank. Okay, in this picture, that red color arrow is shown here. This is the indicator of oil level. Here in this right side, this is the indicator of the oil level. Okay, so whenever you are in operation duties and you are going in the switchyard for the inspection, then you have to check the checklist, where it is also mentioned that what is the oil level in the current transformer. Okay, so there will be three indication. First one will be the maximum, uh, mm, center, and minimum. Okay, it should not be minimum. If it is in a minimum, then report to your boss and take immediate action. So on this site where I went and visited the main root cause analysis, we found that the oil level was low. This was the reason that city blasted. Okay, so I will recommend you to please check the oil level always, okay. And except this point, you have to take care of all the points, okay. So there on that side, what happened, that oil level was low, so for cooling purpose there was no oil, and continuously that CT was charged. So what happened, there was a heating effect in the winding, and that insulation paper used in the winding got burnt, and in such a way that CT blasted. Okay, so this is the thing I am just sharing with you. Next point is that if that CT is SF6 gas type, that means if SF6 gas is used for the cooling purpose of the CT, okay, then you have to check that SF6 gas must be above suggested level by manufacturer. That means this arrow color is so arrow, this red color arrow is shown in the picture, okay. There will be one gauge, pressure gauge, that will show you the gas pressure of the SF6. It should be above the suggested level. That means that it should not be in the red zone. If it is in a red zone or below the level, then you must have to report to your boss or take immediate action. This is very much important, okay. So such type of the CT will be, whenever you see such type of CT, you just guess this is SF6 gas type CT, okay. So next point, the fifth point is that more ampere should not flow through the CT than its normal rating. That means if the rating of CT is maximum 1000 ampere, then but if if 2000 or 1500 ampere is flowing through the primary, then you must have to uh, switch off the load. Otherwise there will be the heating effect, because that is exceeding the capacity of that current transformer, and due to this heating effect the current transformer will blast. So when we summarize, then there are 5 points that we discussed. Secondary circuit must not be kept open. Second, never disconnect secondary circuit from burden. Third one is that oil level must be above marking level in CT winding tank in case of oil type, and in case of SF gas type, SF gas must be above suggested level. Okay. And fifth is more ampere should not flow through CT than its normal rating. So these all things is a point for your experience also, and you must know as a knowledge, because if you go in the interview, this all things will be asked as an experienced guy. So how did you feel? If you know, if you understand that you gain something, then please subscribe for on-site practical and electrical video, and don't forget to like. Okay, thank you. Bye bye.